Hello, good afternoon to all of you. I hope all of you are doing well. So, in today's class, we'll be learning about tokens, expressions, and control structures in C++. Now, a token is the smallest element of a program that has some meaningful resemblance to the compiler, or that is of some meaning to the compiler. So a token is the smallest element of the program that has some meaning to the compiler. So tokens can be classified into following categories. So you have C++ word, you have constants, okay, you have special symbols, and you have operators, right? So now let us try to focus on what is C++ word. So C++ word basically means word that are allowed in a C++ program. So there are two categories of C++ word. One is called as keyword, the other one is called as identifier. So keywords are predefined words which cannot be altered, and identifiers are user defined words, because in a C++ program you may be requiring keywords and you may be requiring identifiers. So the basic distinction between keywords and identifiers are: keyword is a predefined word and identifier is a user defined word. Now, identifiers can be used for naming variables, constants, functions, arrays, and so on and so forth. So that is the purpose of the identifier. Now, the next C token that you have is constants. So constants can be numeric in nature, or constants can be having a character orientation. So you have numeric constants, you have character constants. So in numeric constants, you have integer constants and you have floating point constants. In case of character constants, you have single character constants and you have strings. Okay. Now, in case of special symbols, you have list of special symbols that are allowed to be used in a C++ program. Okay, and you have operators. So operators are symbols that trigger certain action whenever it's encountered in a particular program. So we will learn about different types of operators as well. So now just let us go through it again. So tokens are the smallest units of program that has some meaningful resemblance to the compiler or meaning to the compiler. So there are different types of C++ tokens. So you have C++ word, you have constants, you have operators, and you have special symbols. Okay. So in C++ word, you have keywords and identifiers. Keywords are predefined words, and identifiers are user-defined words. Constants are can be numeric constants, or it can be either character constants. Okay, and you have special operators, and you have special symbols, and you have operators. Now let us move on to keywords, and let us try to understand what a keyword is all about. So keywords are predefined words or reserved words in programming language. So any programming platform, it provides a set of words with which meaning has been already associated, and whenever these words are encountered in the program, the compiler interprets in accordance to the meaning that has been placed. So keywords are predefined words or reserved words in any of the programming language. So in case of C++ also, there are a set of keywords that are defined. Now each keyword is meant to perform a specific function in a program. So whenever you use a particular keyword, the very purpose of the keyword is to perform some specific function in the program. Now, since keywords are referred names for a compiler, they cannot be used to name a variable, because on doing so, what you'll be doing is you'll be creating alternative definitions for keyword, which should be avoided, right? Okay. So since keywords are referred words, so what you cannot do is you cannot redefine keywords or associate additional meaning to the keywords. That is what the next point implies. So you cannot redefine keywords, right? So in case of C, there are 32 keywords, which in case of C++ is enhanced by adding a new set of keywords as per ANSI standard. Okay, we'll come to that. So there are 32 keywords in C, which has their own specific meaning. Now, at the time, it may be difficult for you to recall all the 32 keywords, but it may be very easy for you to recall if you recall it in a manner that all the names of the data types, may it be fundamental data type or derived data type or user defined data type, all the names of the data types are keywords. So, for example, integer, float, character, void, these are keyword. Okay, structure, union, enum, type def, these are keywords. Okay, so names of all the data types are keywords. Okay, names of all the qualifiers are keywords. If an example, long, short, constant. Okay, right. okay, double, these are all keywords. Names of all the decision making statements are keyword. For, if, while, do, right? Okay, switch, associated with switch you have case and label, so these are case and default, these are also keyword. Return is also keyword. So if you remember this particular manner, it will be very easy for you to identify the list of keywords. So in case of C++, we have additional set of keywords being associated, being incorporated by ANSI. ANSI stands for American National Standard Institute, Standardized C++. So we have set of keywords that are being associated. Now, identifiers. So, identifiers are user-defined words, as I've already said. These are user-defined names consisting of arbitrary long sequence of letters and digits, which can either start with a letter or an underscore, but it cannot start with a digit. So, that is one of the criteria for identifiers. So, identifiers are user-defined words which are arbitrary long sequence of characters and numbers, but it has to start with an alphabet or underscore. It cannot start with a number. So, identifier are used for in case of general terminology for naming the variables, naming the functions, naming the arrays, naming the use-defined constants, and so on and so forth. So that is the purpose, the very purpose of identifier. So identifier name must differ in spelling and case of that of keyword. So you cannot have identifier with the name of a keyword. So you cannot use keyword as identifier. These are reserved for some specific purpose. So once declared, what you can do is you can use identifier for holding value at a later point in time. Now this is a very much this is a very important statement. Okay, why? Because what you cannot do is you cannot use an identifier before it is declared. Okay, right? It has to be declared first, only then it has to be used. Now, this particular problem is called as forward referencing. Okay, right? Okay, so this should not happen. So a variable has to be declared first. Okay, an identifier has to be declared first, only then it has to be used. So a special kind of identifier called a statement label is used in collaboration with the goto statement. So whenever we want to create a backward jump, or whether we want to skip a portion of the code, what we do is we use goto statement. So associated with goto, what we have is we have labels. Okay, associated with goto, what we have is we have labels, and these labels are also identifiers. Okay, now there are certain rules that you need to follow whenever you're naming an identifier. So as we have already said, it has to begin with a letter or underscore. It must consist of letter, digit, or underscore. Underscore is the only special symbol that is allowed. Okay, no keywords are allowed, no white spaces are allowed, and there's no limit on the length of the identifier. Right, now likewise constants. So constants are also like normal variables, but it only differs in a manner that it cannot be altered during the course of the program execution, right? So constants, they have fixed value which cannot be altered during the course of the program execution, though they are also called as literals. So constants may belong to any of the data type. It may be of type integer, it may be of type character, it may be of type float, right? Okay, so depending upon the requirement, what you can do is you can create different types of constants. So types of constants, so we will be trying to quickly pan through the different types of constants. Okay, so we have integer constants, we have real or floating point constants, we have octal and hexadecimal constants, we have character constants, we have strings, right? Okay, so integer constants are constants that are composed of all right, so values like 0, 1, so the example cited there. So real or floating point constants are constant that has a integer part and a fraction part, right? Octal constants are constant that has composition of 0 to 7. Hexadecimal has a composition of 0 to F. Decimal has a composition of 0 to 9. Okay, so again I'll repeat it. Octal has a composition of 0 to 7. Hexadecimal has composition from 0 to F, and decimal has a composition from 0 to 9. Okay, octal is represented with the help of a leading 0. Hexadecimal is represented with the help of leading 0x. Okay, and decimal in a very simple term. So that is the way how you differentiate between octal, hexadecimal, and decimal constants. So character constants, single character constants are represented with the help of single quotes, whereas a string is represented with the help of double quotes. So that is the major distinction between a single character constant and a string constant. Okay. Now, again, we have cited here that a string has to always terminate with the help of a null character, because you see the physical termination of a string and a logical termination of string may not match. So just see here in this case, right? In this case, here the size of the string is 20, but we have less than 20 number of characters being initialized to string. So physically, it ends with 20 bytes, right? Logically, it ends with 5, 6, 7, and 8 bytes. Okay, right? So in order to logically terminate a string, what we do is we use a null character. Okay, right? This is very much important, right? So a string terminates with the help of a null character. This is what you need to remember. Right. Okay. So string terminates with the help of null character, but whenever you're initializing a string with the help of is another string, so the null character is implicitly placed. Implicitly placed. So you need not explicitly place the null character here, neither in this case nor in this case. Right. Okay. Here, what we have not done is we have not specified the size. So depending upon the number of characters that are being initialized, number of characters in the strings that is being initialized, what we do is we determine the size of the string. Now, special symbols. So there are a list of special symbols that are allowed in C++ program. The special symbols are pair of brackets, pair of parentheses, right? You have curly braces, you have comma, you have colon, you have semicolon, you have asterisk, you have assignment operator, and you have hash, which is used in preprocessor directives. Now, just see all of these special symbols. They have their own specific purpose whenever you write a C++ program. Now let us move on to the next token that's called as operator. So operators are symbols that trigger certain action whenever applied to a C++ variable and other objects. Now to see here, what we have done is we have included objects as well, because operators can be overloaded in order to perform different operations. That's what we have learned in the previous classes in GIST. So operators are symbols that triggers a specific action whenever applied to a variable or operators, right? The data items on which the operators perform action, these are called as operands. So data operator performs action on operands, right? Now there are different ways in which operators can be classified. One of the classification is based on the number of operands it has, right? Okay, and the next classification is based on the number or the type of operation it performs. Just see, what you can do is you can classify operators based on the number of operands it works upon. So for example, you can have three categories of operands based on the number of operands. So you can have unary operator, that means an operator that works on one operand. You can have binary operator, that means the operator that works on two operands. You can have ternary operator, operator that can work on three operands. So depending upon the number of operands, you can have either unary operator, or you can have either binary operator, or you can have either ternary operator. Right? Now, likewise, depending upon the type of operations, operator can be classified into arithmetic operator, relational operator, logical operator, increment and decrement operator, assignment operator, conditional operator, and bitwise operator. Now let us quickly go through the various types of operators that are there in each of these categories. So arithmetic operators are operators that performs arithmetic operations. Okay, so just remember, arithmetic operators are operators that performs arithmetic operations. So you have plus, minus, multiplication, division, and modulo. So plus adds two number, minus finds difference between two numbers, asterisk performs multiplication of two numbers, division performs division amongst two numbers, okay, modulo performs gives you the remainder of the division operation. So here division gives you the quotient, okay, division gives you the quotient and modulo gives you the remainder. So plus adds, minus finds the difference, asterisk performs multiplication, slash performs division of one number by the other, it gives you the quotient, and a modulo gives you the remainder. Now what you need to remember is that all of the operand except modulo can be used for all the data types, okay, right? So plus can be used for integer as well as floating point, right? Likewise division can be used for integer as well as floating point, but modulo is only defined for integer, right? Okay, so this is what important thing that you need to remember. Modulus operator is always defined for only integer. Likewise, we have relational operators. So relational operators are operators that are capable of establishing relationship between expressions. Okay, so you have greater than, less than, equals to. So these are the three basic relational operators that you have. You have greater than, less than, and equals to. And all the rest of the three are complements. So complement of greater than is less than equals to, complement of less than is greater than equals to, and complement of equals to is not equals to. So this is what relational operators are all about. So operators that are capable of establishing relationship between various expressions. We have greater than, less than, and equals to, and the others the complement of the basic relational operators. So now what we have is we have the next category of operators as logical operators. So you have and, or, and not. So and performs logical and, that means based on the truth table of the AND gate, the implementation of the operator has been realized. So it is AND between two expressions or between two expressions, not. Okay. Now what we have as the next category is the increment and the decrement operator. So increment and decrement operators are unary operators that are capable of incrementing the value of a variable or decrementing the value of a variable, right? Okay, so plus plus is a unary increment, so it means it will increment the value of variable by 1. So if I write plus plus a or a plus plus, it means it's incrementing the value of a by 1, right? Decrement, so it will decrement the value of a by 1. Now there are two forms of increment. It's called as pre-increment and post-increment. So if the operator precedes the operand, it's called as pre, and if the operator precedes the operand, it's called as post, right? Again, so plus plus a and minus minus a is pre-increment and pre-decrement. A plus plus and a minus minus is post-increment and post-decrement. Now just see, there is no difference in the meaning between the pre-increment and the post-increment. So plus plus a is not different than that of a plus plus. Okay. Likewise, minus minus a is no different than that of a minus minus. Both means you are incrementing the value of a by 1 or decrementing the value of a by 1. So plus plus a plus plus means a is equals to a plus 1. Minus minus a minus minus means you are decrementing the value of a by 1. So a is equals to a minus 1. So may it be pre or post increment, basically means the same thing. You are incrementing or decrementing the value of variable by 1. But the difference lies in the way how they are applied to an expression. So z is equals to a plus plus and z is equals to a minus a plus plus a may hold certain difference in a way that in the first case, if z is equals to plus plus a, so it's pre-increment, so a will be first incremented and then a will be initialized to z, and z is equals to a plus plus, so a will be first initialized to z and then a will be incremented. So in the former and the latter case, there will be difference in the value of z, but a remains the same. So now I'm not citing the example here because I want you to write the program for this and just try to see or realize the way how the increment and decrement operator works. Now what we have, you have the next category of operand that's called as assignment operator. Now assignment operator is used to assign the value of an expression or a variable to a variable. Right, okay? Just see, the source can be either expression or a variable, but the destination will always be a variable. And you can have a shorthand operator defined for it. So you can have, so if you want to, if you have an expression that a is equals to a plus b, now what you can do is you can replace a is equals to a plus b by a plus equals to b. So what we have is we have a very simplified representation of a is equals to a plus b, that is a plus equals to b. So that is the purpose of the shorthand operator. So for computational ease, what we do is we use shorthand operator. Now we have conditional operator. So conditional operator is a ternary operator which has which works on three operands. So it works on value of expression. So if there are three expressions, so one before the question mark and subsequently two separated by the colons, right? So if the first expression is true, then expression 2 will be executed. If first is false, then expression 2 will be executed, right? So if expression 1 is true, then expression 2 will be executed. If expression 1 1 is false, then expression 3 will be executed. So here what I'm not why I'm not citing example is because I want you to write a program and realize the working of the conditional operators, right? So likewise we have bitwise operators. So we have bitwise and, bitwise or, bitwise negation, and bitwise exclusive or. So it performs bitwise operation on the values of the operand. Okay, so it will convert each of the operand in terms of its binary component, and then individual bits are selected to perform operations. So that's why it's called as bitwise operation. And we have special operator that is called as comma operator that is used to separate the expressions. So in today's class, what we have learned about is we have learned about what is a token. We have learned about what are different composition of the tokens. We have learned about C words. We have learned about keywords and identifiers. We have learned about constants. We have learned about different types of constants. We have learned about the way how the constants are expressed. We have learned about different types of special symbols. We have learned about operators. Okay, we have learned about in depth what are the characteristics or the essential features that a keyword has in it. Right. We have learned about how many keywords are there. We have learned about how ANSI has extended the keyword repository of C. We have learned about identifier. We have learned about the very purpose of the identifier. We have learned about how identifiers are to be named and how identifiers are to be used. We have learned about few of the important rules for naming identifiers. We have learned about constants. We have learned about the characteristics of constants. We have learned about different types of constants that are there, right? We have learned about the significance of null character for terminating the logical terminating the string. Okay, a logical terminating the string. We have learned about different types of special symbols that are allowed. Okay, we have learned about different types of operators. We have classified operators based on the number of operands, and we have classified operators based on the type of operation it performs. Okay, so in the next class we'll be moving ahead with the chapter, right? So thank you very much. Have a very good day and stay safe.